So we're on to hexadecimal. So far, you can see what we've had in common between these three numbering systems is that they all use the same digits, right? Well, I mean, like this digit, this one is here, this one is here, this one is here, which is good. That means we'd be able to count all the way up the bases, all the way up to base 10. But what happens after base 10, right? What happens if you want to show more numbers than that, right? Like 9 is the highest numerical value that we have right now. So what do? Well, we can represent the underlying value with different characters, right? We don't necessarily need to use a 9. So let's go through, right? And let's start up. So this is zero. This 0 right here is actually base 1, right? Because we can represent one value, and that is this plays into like array numbering, stuff like that as well. Is one of the big flaws, right? If you go into like programming, is like an off by one error, or when it's going through and it's cycling through an array, right? And the programmer might not view that 0 is the starting value, right? So they might miscalculate where the end of that array is. And 0 is a value, right? This is a base 1 right here because we can show one value. That value is nothing, but we can show one value. This is 1. This is one digit. We have one thing we can show, and you're like, okay, I get it. And like, this is important because this is what causes errors for off by ones and other programming logic errors that occur, is because of this. Is because this is actually base 1, right? And this is base 2, as we saw. We see base 3, base 4, base 5, base 6, base 7, or yeah, base 8, base 9, base 10 decimal. What happens? We need other, right? We need more representations for values. What are we going to do? Well, why don't we use letters, right? And that's what happened. Is A is 10, B 11, 12, 13, 13, 14, 15. So we now have 15 right there. With the 0 is 16, right? So this right here is hexadecimal. And the same hexadecimal, the same rules apply, right? How do we now count with this, right? Well, let's take our trusty text tool and go down, right? So let's say we start at 0 and we're counting up like we normally do, and we get to 9, and we say, oh, well, we can actually keep going, right? We can go all the way up to 15 with this by just using numbers. So we'll go through and just do A, B, C, D, E, F, right? So we're at 15. What happens? We are now out of the available characters representations that we had. What do? Well, we do the same thing, right? This all here that was occurring is once again just a 0 column behind it. Like I said, if you're looking at this, like, say, once again, it's because the videos, they're made to go in order. I'm recording them right after another. I just broke them up. So if you watch from the beginning of the videos, you can move on through it. But this is what's actually occurring behind it. We're out of the available representations. What do? Well, let's change that 0 to a 1 and continue on, right? So this here, you look at it right now, you're like, why are you writing 11 and 12? I'm not, right? Once again, this is a representation of 16. Because we did 15 here, we needed to carry 1 over so that we could have 16, 17, 18, or sorry, I wrote 19 because my brain wanted to. 19. So 16, 17, 18, 19, right? And all we're doing is we look at this first digit here. So we are now going to take whatever's in this first column and we're going to multiply it by 16. And we're going to take whatever is in the second column, which is still 1, and we're going to multiply it by 1. It's still a 1 value, right? So when you see this, you now see whatever's in this first thing, we're going to times it by 16, and then we're going to take the next column and we're going to times it by 1, and then we're going to add them together, and that's going to give us our output. So when we see this here, we see 13. What does this actually mean? Well, we take the 1, we multiply it by 16, which gives us 16. And then we add in the 3 times 1 is 3 equals 19, right? And that's all it is this underlying. It's hard because you're so used to growing up and you see 13, you're like, oh, that value, that is a value, but it's not. It's a representation, remember? This actual representation, this represents the value 19. And that's something that when you start looking at numbers like this, it'll make your understanding of like low-level assembly stuff like that a lot easier. A lot of times you'll see in assembly the prefix of 0x and then like a2, a3, something like that, right? Like 0x here is normally showing that it's going to be in a hexadecimal format. So that's pretty much all hex is, right? And just like that, you went through decimal, binary, octal, hexadecimal, but you can take hopefully what we learned in these last videos and you can go into almost any base system that you want, right?